Okay, thank you for watching the videos. Finally, we've got to today's lesson. And I've opened up the specification. What I want to point out is at the moment we've looked at variables very briefly. We've looked at input, output very briefly. We've looked at constants. We've mentioned the word global. And we've looked at assignment, but we haven't really gone into a great deal of detail. And I want to start by looking at this word data type, because this is really what computing is all about. And so I'm going to try to explain data type. And if we look in this column here, we've got str, which stands for string, int, which stands for integer, whole number. We've got float, which is a decimal number, and we've got real, which is a decimal number. Bit weird, why would we have two of those? And we've got something called bool, which stands for boolean. Now, these are the main data types, but not all of the data types that we'll use in the course. Once we've learned these, we will move on to a few others which are a bit more complicated, but hopefully we will learn as we go along. So here's some examples over on this side. That there, 3, is a string, and we're converting it to an integer because this is called casting. And casting means converting from one data type to another. But I've got to teach you what these data types are. So I'm just giving you an example. And this is a decimal number. This is a decimal number because it's got a decimal point in. This is a whole number. This is a whole number. All of these are strings because they're in quotes, and we're actually converting them. But this is bool. Bool can take one of two values. It can either be true or it can be false. It's short for boolean, B-O-O-L-E-A-N, and we will look at that a little bit later. But I'm really not interested at the moment with these. I want to go sort of back in time to why do we have different data types. So this is my introduction to data types. What you need to learn is what a byte is. Now this is a good area for sort of investigation online. Don't be worried about sort of searching up what you need to look at in Google. What I'm saying and my lessons may cover the majority of things, but I won't cover everything, and you will learn more when you go searching. So this is something called a byte, and a byte contains 8 bits. 1, 2, 3, 4, 5, 6, 7 and 8. And a bit is just one of these items. So if I was going to do a bit or have a type called bit, where's my text box? There we go. If I wanted a text box, we've got something called a bit, which is a single binary digit, and that's what this really stands for. A bit is short for binary. Let's stretch that out. I'll get used to this. Binary digit. Okay, so we've done binary before, but we need to revisit binary and start understanding what it means. But at the moment, a byte is 8 bits. So a byte is 8 bits. I'm not having much luck with my computer this morning. 8 bits. Now, this so happens to be the smallest type of information that can be stored in a computer memory. And here's my impression of a computer memory. It does go on forever, so I've got, I think, 8 down there, but It goes on forever. There are billions of these boxes. That's computer memory. This is my representation of a byte. So instead of keep putting the ones and zeros in there, I've just got a little blue box which represents 1 byte, 8 bits, and each memory location, okay, can just hold 1 byte. So if I want 2 bytes in memory, there we go. Each memory location can hold 1 byte, no more. Okay, so now I've got 4 bytes in memory. And this is really where data types come in. So we saw here that we've got different data types: string, int, float, real and bool. So I'm going to try to explain those now. So first of all, I'm going to describe an integer. And what an integer is a whole number. Okay, an integer is a whole number. And for our purposes, let's say that the integer, we can represent a whole number. Let me just move these out of the way. There we go. A whole number can be represented for our purposes by 1 byte. So that would be an integer. So if I got 2 integers, I would have 2 bytes. Okay. Now we had something called a real, and a real is a decimal number. So a real is a decimal number. Now let's think about a decimal number. With an integer, a whole number, we just had the number itself. With a decimal number, we've got 2 bits to it. We could have 3.45.678. Okay, so we've got 2 bits to it. Now let's imagine that we need 1 byte to be for the 345 and another byte to be the 678. So if I can write in here 345 and the 678, a real number requires 2 memory locations. So if I stuck a real number into my memory, I would need 2 locations. Come on, I'll grab hold of it. There we go. So that will be a real number. This would be my integer. Let's just put a simple number in there like 23. So an integer would take up 1 space in memory, and a real number would take up 2. Now, a float. A float is exactly the same as a real, but it's bigger. Okay, but I don't think you need on this course to worry about the difference between a real number and a float. So basically all it's saying is instead of having 2 of these to represent it, oops, there we go. Instead of having 2 to represent it, it would have 4 bytes to represent a float, or called a floating point number. That's because the decimal point can float. It can be in between the 3, it can be between the 4 and the 5, between the 6 and the 7 and the 8. But in memory, it requires 4 bytes. Okay, so that's a whole number. A whole number is small, just has one location in memory. A real number is or requires two locations in memory for the bit before the decimal point and the bit after the decimal point. Float we can ignore for the time being. There's no difference between the two as far as your programming goes at all. You'll never reach the point where you need to think about this. So if you use real for a decimal or float for a decimal, that is fine. There's even more words for them. There's quite a lot of different data types because of size in memory that they use. So what I'm going to do now is I'm going to have a string. So let's get a text box. And a string is a list or a string of characters. Now, and finish that off with each character occupies 1 byte. So for example, if I wanted to write the word hello, each one of these bytes would contain a character. Okay, and then they would fit into memory. Whoops, let's put the E in, let's put H in. The L in and the O in. So there you go. So the string fits into memory 1 byte at a time for each character. Now, strings can be rather large. They can be up to 255 characters long, and some computers it's even longer, but we'll have a maximum amount of 255 characters. But what I want you to notice is that the whole number is fixed at 1 byte. Okay, the real is fixed at 2 bytes. We're going to ignore the float. Let's get rid of that. I just needed to mention it because it is actually on this document here. Oops, I've lost my presentation. And a string is up to 255 bytes. The thing is, they are all different sizes and they can't be mixed. The last one that I want to talk about is a Boolean. So a Boolean can be true or false, and we shorten that to bool. A Boolean can be true or false. And the magical part about that as far as storage goes is we only need 1 bit to store the value, e.g. true equals 1, false equals 0. So I can use 1 or 0 for a Boolean, so I only need 1 bit. So actually in 1 byte I could store 8 different Booleans. So it's only going to take up a small amount of memory. So an integer is fixed at 1 byte. A real number is 2 bytes. A string is up to 255 bytes. And true or false is just 1 bit, a really, really small amount of memory. Now, that's my introduction to storage and why we use different data types. And the important part is, this one is they cannot be mixed because they are different sizes. So if I write here, they cannot be mixed because they are different sizes. So what do I mean by that? So I'm just going to finish off now quickly. Let's imagine that I've got this real number, which is 345.678, and that is 2 bytes long. If I wanted that to be an integer, I'd only end up with 345. I would lose that second byte. So I can't sort of store a real number as an integer because I would lose that portion. And the same with the string. If I was trying to store hello as an integer, I could only store the H. The ELLO would be kind of lost. And again, with a Boolean, 1 bit, I would need 8 of them to be a byte. So they're all different sizes, and we need to be careful how we play with them. So going back to our document, we've got this thing called casting, which is a special thing that the computer does to convert one data type into another. So here I've got 345 as an integer. So the 345 is an integer. I'm going to convert that into a string. What it's going to do is take the 1 byte and convert it into 3 bytes, being, let's try it out on here. No, it's not going to let me play. Okay, let's put something in here. So there's my 345 as an integer. And let's paste a couple more. To convert that to a string, I would need to represent it like this. I'm still not getting in. There we go. So that would be 3. That would be 4. And that would be 5. So I would convert my 345, 1 byte, as an integer, represent it as a string, but I would need to use up 3 bytes of memory to do it. So that is roughly what is meant by casting, changing the size of what is stored. But we'll come back to that as we go through. So we're going to start looking at strings, ints, floats, reals and booleans from now on.